For problem 3, we will have charge Q1 at distance y1 along y, and this charge we call it Q1, and this is positive. Then we will have charge Q2. It will be at point x2, y2, and we will have third charge. And third charge will be negative. It will be minus Q3, and it will be located at x3 and y3. So we want to find force exerted on charge Q2 by charges Q1 and minus Q3. Find the force on Q2. From Coulomb's law, we know that magnitude of the force between two charged particles is coefficient k, and then magnitude of one charge, magnitude of another charge, divided by distance between them squared. So we will use Coulomb's law, and we will use principle of superposition. So we will find force exerted on Q2 by Q1, and this force will be repulsive force in this direction. We will call it F1. Force exerted by minus Q3 on Q2, this is Q2, will be attractive force along this line. This force will be F3. And we will use principle of superposition. So we will find each force separately, F1 and F3, and we will add them as vectors. So what we need to do now, we need to express F1 and F3 in terms of components, and then add x components and y components to find the resultant. We will start with F1. F1. Magnitude of force F1 will be coefficient k, according to this law. Then product of Q1 and Q2, Q1, Q2, divided by distance between them squared. To find distance, we will use this right triangle. So I'll draw this line that is perpendicular to y, and then we will use this right triangle to find the distance between two charges. This distance is hypotenuse of this right triangle, and it is x2 squared plus y2 minus y3 squared, x2 squared plus y2 minus y3 squared. Distance squared, this is magnitude. Now to find x component, we need to project it in x. This line is parallel to x. I draw a line perpendicular to x. This is my right triangle. So I will use this. This will be my x component of F1, and this will be my y component of F1. To find x component, I need to take hypotenuse, the magnitude of F1, and multiply it by cosine of this angle theta, cosine theta, and this will be Ix, unit vector Ix. And then y component is positive, magnitude is k q1, q2 divided by distance squared, which is x2 squared plus y2 minus y3 squared times sine theta. Sine theta. And this will be IY. So what is sine theta and cosine theta? This angle is theta, then this angle is also theta, and we will use this triangle to find sine theta and cosine theta. So sine theta is equal to opposite leg, which is y2 minus y1, y2 minus y1, divided by hypotenuse, which is x2 squared plus y2 minus y3 squared square root, and cosine theta is equal to, adjacent angle is equal to x2, adjacent leg, x2, divided by hypotenuse square root of x2 squared plus y2 minus y3 squared. This is sine and cosine. And now I bring sine and cosine here in my F1. So what will be F1? F1 is, I factor out K, Q1, and Q2. So K, Q1, Q2, I open brackets. Then from cosine theta, I will have x2 divided by this guy, and square root of the same guy will bring me to x2 squared plus y2 minus y3 squared to 3/2. And this is Ix plus sine theta, k, q1, q2 is already here, sine theta is here, so it is y2 minus y1 divided by x2 squared plus, I'm right here, y2 minus y3 squared to 1, and square root of the same guy from sine will bring me to 3/2. And this is IY. And we close brackets. So this is F1. Now we need F2. So what will be no, not F2, but F3. We called it F3. What will be F3? F3 is in this direction. Magnitude of F3 will be K. And then Q2, Q3. Do I need to put here Q3 or minus Q3 in magnitude? So we understand that Coulomb's law tells us that for magnitude of force we have absolute value of Q1 and of Q2 and Q3. So I put here magnitude of Q2 and Q3. No minus here. No. So Q2, Q3, I divide by distance between them squared. I will use this triangle. We will draw it in blue. I will use this triangle to find distance between them. This is hypotenuse, which is x3 minus x2 squared, x3 minus x2 squared, plus this leg squared plus this leg squared, and this leg squared will be y2 minus y3. y2 minus y3 squared. Distance squared. Now what I want to write x component of force F3. Now I need to project F3 on x. Which triangle we will use? So let's just draw a line that is perpendicular to x. This line. This is F3. Then this will be F3. I take blue. This will be F3x. and this will be f3y. We understand that f3y will be negative, but f3x is positive, so I keep plus here. To find x component, I need to multiply this hypotenuse on cosine, let's say phi. Let's call this angle phi. So x component, I write length hypotenuse times cosine phi, and this will be ix. And then y component is negative. I put minus k, and then q2, q3 divided by distance between them, which is x3 minus x2 squared, plus y2 minus y3 squared, distance squared. Now for y component, I need to multiply by sine phi, and we don't forget y. So now we need to find out what is cosine phi and what is sine phi. So cosine phi is equal to, which triangle we will use? So this angle is phi, then this angle is also phi. Let's use this triangle to find out what is cosine phi. Cosine phi is adjacent leg, which is x3 minus x2, and divided by hypotenuse, which is x3 minus x2 squared, plus y2 minus y3 squared, and square root. And now sine phi. What is sine phi? It is opposite leg, which is y2 minus y3, divided by hypotenuse, which is x3 minus x2 squared, plus y2 minus y1 squared, square root. And now I bring cosine phi and sine phi in my formula for f3, so we will find f3. I will factor out k, q2, q3. K, q2, q3. And then in parentheses, in brackets, I will have from cosine phi, I will have x3 minus x2 divided by this guy, x3 minus x2 squared, plus y2 minus y3 squared. This guy. And the same guy from cosine phi, square root. So eventually I will have this guy, 1 plus 1/2 is 3/2. And I don't forget ix. And then minus k, q2, q3 we factor out. Then sine phi is y2 minus y3. We divided by this guy to 1, and the same guy to 1/2 from sine. So I have x3 minus x2 squared plus y2 minus y3 squared, y2 minus y3 squared, and this to 3/2 iy. And I close brackets. So we found F1 and we found F3. What we need to do next, now we need to add them as vectors, which means that we need to add x components and y components together. Force F, net force acting on charge Q2, will be equal to F1x plus F3x. I add x components of these two vectors, and this will be my x component of the resultant. And then we have F1y plus F3y, and this will be my y component of the resultant. So let's keep going. What is F1x? F1x is right here. So I have K Q1 Q2, K Q1 Q2, x2 divided by this guy, which is x2 squared plus y2 minus y3 squared 3/2 F1x. Now I need F3x, which is this guy. So it is plus K Q2 Q3 divided by times x3 minus x2 divided by x3 minus x2 squared plus y2 minus y3 squared 3/2. And this is my x component of the resultant, so it is Ix. And now we need to add y components, so we need to keep going, and I will erase x component f of f1, and we will keep y component of f1 so far because we need it. I will just rewrite it. So it is positive. I will bring this piece right here. So plus f1y is right here. We have k q1 q2 and then y2 minus y1 divided by x2 squared plus y2 minus y3 squared, and all this 3/2. This is f1y. We don't need it anymore. We brought it here. And then I need f3y, which is negative. So I put minus. And then k q2 q3 y2 minus y3 and divided by x3 minus x2 squared plus y2 minus y3 squared to 3/2. And all this is y component of the resultant. So my net force F acting on charge Q2 is x component of F and y component of F.